Welcome back to this series of math videos. Today our focus is on the circle and the ellipse. We'll be looking at outcomes like these: finding the center and radius of a circle, finding the vertex and the foci of an ellipse and drawing the graphs, and then looking at equation of ellipses and circles and all their characteristics. To begin with, the basic concept of this unit deals with looking at an equation, understanding the concept of the particular relation that you're looking at, whether it be a circle or whatever, and getting some information from that. For example, in the past we've looked at linear functions where the equation itself tells us a slope and a y-intercept. We've looked at quadratic functions where the equation tells us the y-intercept. From the equation we could factor and determine x-intercepts or characteristics of the graph. Again, in this quadratic equation here, we have it in a different format, and this can give us the vertex of that parabola. Today we'll be looking at circles and ellipses, and again looking at the equation of the circle or the ellipse and trying to draw information from that. So, to define a circle, and this may be a definition you've heard before, but a circle can be defined as a set of all points such that they are all equidistant from a fixed point called the center. So if I take a look anywhere around that circle, I should be able to see that the radius is looks consistently to be about 4. So it's a set of all points. I'll put some points along the outside here. Set of all points that remain a similar distance or an exact distance away from a fixed point called the center. Now, we can look at the equation of a circle then as a way of defining how far away from that center point the set of points are. And there are two characteristics that we look at in particular with a circle. The first is what the center of the circle is, where the middle is. Is it at the origin, or is it located somewhere else? And also what the radius of the circle is. Remember, with straight lines, there were two things, slope and y-intercept, that characterized that line. Same thing with a circle, where the center is and what the radius is. So if we can get the equation of a circle to be in this format, then I can draw from that what the center of the circle is and what the radius is. So let's go through the steps in doing that. First off, here's an equation of a circle. I recognize it as a circle because the coefficients of x squared and y squared are identical. They're both positive 1. We'll see with ellipses that they'll both be positive, but the numbers will be different. Therefore, you'll have an ellipse. But in this case, they're both the same sign, same number. This is a circle. Now, if I have, in addition to the x squared term, if I have an x term, that tells me that the center of the circle is not at the origin. It's somewhere else. Similarly, if I have a y term, it also means that, in this case, the y value of the center of the circle is not at 0. It's either up or down somewhere. But what I want to do then is I want to take this equation and make it look like this, which was that standard format for the equation of a circle. I want to make this look like this. So it looks like I have two perfect squares here, in x and in y. So I'm going to try and get perfect squares, or I'll use the complete the square process to get this. First off, let's group the x terms. So x squared minus 16x. Let's also group the y terms, y squared plus 14y. And let's move the 32 over to the other side. Okay, not too bad. I've got x's, y's, and a number over here. Okay, things are shaping up. Now I need to complete the square. We've seen that before, and to do that you take this term here, the coefficient of x, divided by 2 and square it. So this would be x squared minus 16x. 16 divided by 2 is 8 squared, 64. Plus, we'll do the same thing with the y's. 14 divided by 2 is 7 squared, 49. 49 equals minus 32. Now, when I look at this equation and this equation, looks like I added this in, and I added this in without, making any compensation for it. If I add a 64 on the left side, I can compensate for that by adding a 64 on the right side. Similarly with the 49. So now what I get on this left side here, this is a perfect square. That's what I was shooting for. It's x minus 8 squared. And of course this is a perfect square. Y plus 7 all squared is equal to, now I just have to figure out what this is. So that'd be 32 plus 49, I'm calling that 81. Now I have the equation of the circle in the right format. So I can draw then information from this right format. Let me move my other formula down a little bit. So what I get from this is I can get the center of the circle. And it's always to change the sign there. Since the equation says x minus h, there's a minus in there already, h must just be 8. So the x coordinate of the center is 8. The y coordinate, yep, is a minus 7. And the radius of the circle I get from this number. Now this isn't the radius, but it's r squared, like shown here. So r squared is 81, therefore r is equal to 9. Since the radius is a positive number, that's why I wouldn't put plus or minus there. It's just a positive value. So there we go. Those are the two pieces of information that I need about this equation of the circle. I needed to know what its center was and what its radius was. And so I could graph that if I wanted to. Let's move on to ellipses. Ellipses are defined as being the set of all points whose sum of the distance from two fixed points is a constant. Oh, okay. Well, let's pick a point. We'll pick this point right there. Okay, so the sum of the distance from two fixed points. Oh, so if I take a line and draw it to this point here, and I take my other fixed point, my other focus point, and draw a line there, they're saying that the sum of those two distances are always the same. So for example, say this was 3 and this was about 6. It looks like the sum of those two distances is 9. Therefore, any other point around the whole ellipse, if I put a point in, let's put one exactly halfway. So the distance from this point to my focus and from this point to my other focus, the sum of those two must be 9. So say if this one was 4.5, this one would be 4.5. Or how about a point way over here? Say this distance from here to here, it looks to be about, I don't know, 8. Looks like my numbers are out a little bit, but say that's 8, and this distance here, since the sum always has to be 9, if this long distance is 8, this little one has to be 1, right? So the sum of the distance from our point around the side to these two fixed points, or these two focus points, is always a constant. Now, a couple of pieces of information that we want to know about an ellipse. In a circle, we had the center and the radius. In an ellipse, we've got 3 different characteristics that we want to track because they define the shape of our ellipse. Okay, the first one is the distance from the center out to the longest side. And we call that distance A. Okay, so this distance there is A. So the whole way I guess I could say that's 2a, is called a major axis. Major because it's the longest. Okay, if I've got a point from the middle out to one of the edges here, of course I'm going to have a point from, or a letter characteristic from the middle out to this edge. And that one is called letter B. Also 2b, yeah, you're right, it's going to be the minor axis. Now the only one left to do is letter C, and we've seen what the focus point is and how that helps define an ellipse earlier. But the focus points would be out here somewhere. There's one there, and there's always one on the other side too. There's always two focus points. And those focus points, the distance from the focus point to the middle, is called letter C. So the game with this is finding an equation, or given an equation, trying to figure out what A, B, and C are. Sometimes they only give you two. If they only give you two, there is another formula that I can use to relate those. And it looks very similar to Pythagoras, but instead of having a plus in the middle here, they have a minus. So this is an equation that relates these three characteristics of an ellipse. Now let's take a look at equations then. So here are the two general equations for an ellipse. This first one, notice x squared y squared. Then I have a squared under the x squared and b squared under the y squared. And that ellipse looks like it's laying down. Then, if I look over here, the only difference between these two is that a squared is under the y squared this time. And if I have a squared under the y squared, then I have an ellipse standing on end. Now you may wonder, well, these are just letters. What if I throw numbers in? How can I determine which is A and which is B? In ellipses, A is always greater than B. Whoops, that's sort of funny. I said it right, but I wrote it wrong. A is always greater than B, so it's always larger. So I just look at what the number is underneath, and whichever one's larger, that is A squared. The other one must be B squared. Let's try an equation. Here's one, and we want to plot this. Draw this ellipse. Indicate or include the values for A, B, and C. Yeah, good. Okay, first off, I notice that the equation isn't in the right form. I need something like x squared over some number plus y squared over some other number is equal to 1. Must have a 1 on the right hand side. I have a 4 there. To get rid of that 4 or to get a 1 there, what I'm going to do is divide all terms by 4. So in this first case, I'll come up with x squared. I could just say x squared, or I'm going to put it over 1. Just because I know there has to be a number down there, I might as well write 1. Plus y squared over 4 is equal to 1. So in this case, the larger number is underneath the y squared. Therefore, larger number, A is always bigger, larger numbers under y squared, therefore it must be an ellipse standing on end. Okay, so I've got that. Now, let's determine what those values for A, B, and C are. Let me get rid of this. So, since I know the A is always greater than B, this number under the y squared must be A squared. So A squared must be equal to 4, and B squared must be equal to 1. Well, if A squared is 4, it follows that A is 2. Similarly, if B squared is 1, B must be equal to 1. So those are my distances then from the middle out to an end, although my ellipse is going up this way. So from the middle out to an end, let's call this 1 and this 2. There's one of the ends, and there will be one of the other ends. And B is 1, so the distance from the middle out to a minor axis is there, and the other one is there. So now if I join those sort of in a nice circular, it's not circular, elliptical pattern, I get an ellipse. Mine isn't as good. Hopefully you can draw it better. So that's how I would draw it. The only thing that I haven't done, as I have a and b, is I haven't determined what c is. Let's go ahead and do that. So to determine c, I'll go c squared is equal to a squared minus b squared. So c squared is equal to a squared is 4 minus b squared is 1. So c squared is equal to the square root of 3. Therefore, I'll just put it over here. C is equal to the root of 3. So the root of 3, since this is my major axis, I know my focus points have to be on that major axis. The focus points will be approximately there. I could figure out what the square root of 3 is and get it exactly. I think it's 1.6, 1.7, somewhere in there. Anyway, that's where my focus points will be. And that's what I'd like to see drawn for an ellipse. And so, in this section, we've looked at equations for both circles and ellipses. Circles, we saw, have two characteristics that are important. One is the center, and the other is the radius. For ellipses, we found that I could get an ellipse laying down, or I could get an ellipse standing up on end. Each of those would have an equation that defines them. For example, this one might be x squared over 10 plus y squared over 8 is equal to 1. Notice the larger number underneath the x squared. And this one, the larger number would be under the y squared. Okay, so try some of the questions, and if you have problems, contact your instructor.